Every galaxy in the universe has on average 100 billion stars in it. The vast majority of these stars are small and difficult to see. Cool red dwarfs and dim white dwarfs. Other stars, like our Sun, are yellow and temperate. But there are some stars between 20 to 40 times more massive than our Sun that roam these galaxies like titans. Known as hypergiants, these stars are 3,600 times the diameter of the Sun and are among the most luminous stars in the heavens. They are so luminous because they are devouring themselves, consuming their fuel at fantastic rates. Hypergiants release as much energy in 6 seconds as our Sun does in an entire year. Because they are so active, their lifetimes are measured only in millions of years, which is a blink of an eye on cosmic timescales. There are not many hypergiants known. In our galaxy, among the hundreds of billions circling the heavens, there are only about 10 known stars like these. Among them, a star named VY Canis Majoris, named for the constellation in which it resides. VY Canis Majoris is fitful and restless, its entire lifespan only a few million years. It's a very bright red giant star, its luminosity due to enormous mass loss. This star is losing billions of tons of material every day, which surrounds it like a death shroud. The reason for this mass loss is poorly understood, but it is believed to be due to instabilities in the interior and the exterior layers of the star. These instabilities are usually the progenitor of a supernova. VY Canis Majoris has already shed over half its original mass. It is in the final throes of death and could explode at literally any time. If it exploded today, some 4,900 light years away, the blast wave would slam into the surrounding envelope of material with a velocity of a few thousand kilometers per second and produce what is known as a Type 2N supernova. Also known as a core collapse supernova, these explosions result when the interior of the star can no longer support it, and it collapses at rates of up to 70,000 kilometers per second. This rapid collapse heats the interior of the star, producing high-energy gamma rays that can decompose iron nuclei created during the lifetime of the star into helium and free neutrons and neutrinos. As the core collapses, electrons and protons are squeezed together, producing neutrons and more neutrinos. Since neutrinos rarely interact with other forms of matter, they escape, accelerating the core collapse and slams into the outer layer of the star, triggering the supernova explosion. A neutron star is born. But VY Canis Majoris is so large, many astronomers believe its fate may be even more spectacular. It may die in what is called a hypernova. These outbursts contain more energy than 100 supernovae, emitting enormous quantities of gamma rays when it occurs. These gamma rays can actually pose a threat to nearby stars and planets, and depending on their distance, are strong enough to destroy any life that may reside there. Fortunately for us, if this is in fact VY Canis Majoris' fate, it is so far away that Earth will not be affected. Finally, the core from this hypergiant is so massive that its collapse crushes even the neutrons together. The collapse is so inexorable nothing can stop it, leaving behind a black hole. The spectacle of exploding stars peppers our history. Ancient peoples have recorded many of them. There is roughly one supernova in our galaxy every 50 years. Luckily, for any other life that may exist in our galaxy, hypernova occur even less.